All right, today we're diving into something absolutely fascinating, a fungus that's traveled from ancient rituals all the way to the cutting edge of modern medicine. We're talking about psychedelic mushrooms. For thousands of years, they were these sacred spiritual tools. And now, well, now they're at the center of some really intense scientific study. Let's get into why. So that brings us right to the heart of what we're talking about today. We have this ancient fungus that's kicking off a modern medical revolution. But what do we actually know about it? We're going to dig into its history, its biology, and where it might be headed next in the world of medicine. To really get what's happening now, we have to go way, way back. Long before there were labs or clinical trials, people had this really deep spiritual relationship with these mushrooms. And our journey, it starts right there. The time scale here is just mind-blowing. I mean, this is not some recent thing. We're talking about evidence from 8,000-year-old rock art in Europe and Africa. We see it in Mesoamerican rituals over 3,000 years ago. Taoist texts in China talked about spirit mushrooms. And the Aztec codices from the 16th century, they describe something called Teonanácatl, which literally means flesh of the gods. Humanity's connection with these things is seriously ancient, and it's global. And check out this quote from a 16th century Spanish friar who was watching the Aztecs. It shows just how people back then were trying to wrap their heads around the power of these mushrooms. He notes they were used as medicine, sure, but he also describes the intense psychoactive effects, warning about visions that could be either frightening or humorous. I mean, that's a stunningly accurate description from 500 years ago. Okay, so how does the mushroom actually do it? How does it cook up a chemical that can so deeply change our consciousness? Let's pivot from history to biology and take a look inside the mushroom's own little chemical factory. Think of this as the mushroom's secret recipe. It all starts with a really common amino acid, L-tryptophan. Yeah, the same stuff you hear about in turkey. The mushroom takes this basic building block and, through a few really elegant steps, turns it into psilocybin. And this whole thing, which looks super complex, can really be broken down into a simple 4-step recipe. First, an enzyme called PISD just snips a little piece off the starting molecule. Second, another enzyme adds an oxygen and hydrogen atom. Third, a phosphate group gets tacked on. And finally, in step 4, some methyl groups are added, and boom, you've got a finished psilocybin molecule. It's just a beautiful little piece of natural chemistry. So, now we know how the mushroom makes the psilocybin. But what happens when that stuff gets into our bodies? Let's shift from the mushroom's chemistry to our own brain's chemistry. Right, this is the first really critical transformation. Once we ingest it, our body gets to work and basically removes that phosphate group the mushroom added. This turns the stable psilocybin into psilocin. And psilocin, that's the real star of the show. It's the active compound that can actually get past that super tight security gate known as the blood-brain barrier. And once it's in the brain, psilocin's shape is just incredibly similar to serotonin, which is our brain's own neurotransmitter for regulating mood. So it acts like a master key, fitting perfectly into these specific serotonin receptors, the locks in our brain. And when psilocin turns those locks, it can basically open the doors of perception. But here's where it gets really interesting. Is it just about that one key? Maybe not. This leads us to this fascinating idea called the entourage effect. The theory goes that the mushroom isn't just one compound. It's a whole cocktail of different molecules, and they might all be working together to shape the experience. And this is a huge debate in the field right now. On one side, you have pure lab-made psilocybin. It's what's used in most clinical trials because it's controlled and predictable. But on the other side, you've got the whole mushroom, this complex natural brew. It might contain other compounds that can actually slow down the breakdown of psilocin in the body. And what that means is the effects could feel stronger or last longer, which kind of challenges the whole pharmaceutical model of using just one single molecule. All this complexity is exactly why scientists are so incredibly interested again. After being off limits for decades, research is just exploding, kicking off what a lot of people are calling a psychedelic renaissance. I mean, just look at this graph. It tells the whole story. For decades, it was pretty much flat. Research just stopped. But then, right around 2017, the number of scientific papers on psilocybin just goes vertical. It skyrockets. This is the renaissance we're talking about, in one image. So where is all this new research happening? Well, the lion's share, a whopping 42%, is in neuroscience.
Scientists are scrambling to figure out exactly how this stuff affects the brain. After that, you've got pharmaceutical and biochemical research as the medical world tries to figure out how to turn those brain effects into actual treatments.
And what kind of treatments are we talking about? Researchers are looking at psilocybin-assisted therapy for some of the absolute toughest nuts to crack in mental health. Depression that just won't respond to anything else, the deep anxiety that terminally ill patients face, OCD, and even addictions to things like alcohol and tobacco. And to give you a sense of the jaw-dropping potential here, look at this number, 80%. In one pilot study for treating tobacco addiction at Johns Hopkins, an incredible 80% of the participants had quit smoking 6 months after their psilocybin-assisted therapy. Now, to put that in perspective, most other smoking cessation methods have success rates well below 35%. A result like that, well, that makes the entire scientific world sit up and pay attention.
But, and this is a really important but, all this potential doesn't come without challenges. This isn't about miracle cures. If we're going to move forward, we need to have a really clear-eyed view of the risks and figure out a safe path forward.
And the known risks are significant, for sure. On the psychological side, really difficult experiences with anxiety or paranoia can happen. Physiologically, it's pretty common to see temporary spikes in heart rate and blood pressure. There are also potential interactions with other drugs, especially certain antidepressants. And maybe most critically, there's a risk of triggering psychosis in people who already have a predisposition for it. These are not things to be taken lightly. And this all leads to what is probably the single most important lesson from all the modern research. Context is everything. Those amazing results from the clinical trials, they aren't happening because people are taking mushrooms at a concert. They're happening in very carefully controlled therapeutic settings, with trained professionals providing support. This idea of set and setting is absolutely essential for managing the risks and unlocking the benefits.
So, we've gone from ancient cave paintings all the way to the neural networks of the human brain. Science is finally starting to draw a map for this ancient fungus. But, a map isn't the same as the journey. The next huge challenge is figuring out how to responsibly weave all this potential into the complexities of modern medicine. What comes next? Well, that's the big question we're all going to be watching. Thanks for joining me on this one.